Okay, everybody, hello. I'm going to show you here how we solve equations that have variable terms on both sides of the equal sign. Now, this is the part, these are the equations where kids often, in my experience, um, kids often kind of look at an equation like this, they see more than one x, and they're like, ah, I understood the smaller ones, but the two-step, these ones, it's too much. It's too much, I don't know what to do, okay? But I'm telling you, these just so often, oftentimes with these more complex equations, it takes an extra step or two in the beginning, okay? But then once you get it down to a spot where you are comfortable, like maybe you watch the two-step equations videos and you're like, I get that, but I don't get these, okay? So let's make your goal with these to get it down to where it looks like a two-step equation. And then you know what to do from there because you know the pattern. Um, so just watch what I do here. And don't, again, just so often with math, it's easy to just, I give up. Okay. But I'm telling you, it's really valuable to just persevere and work through it and try to understand it, because you'll be better off as a result of it. Okay. So let's work through this first one. Okay. And then I got two more examples on the side there. Okay. So again, I call it variables on both sides because they have exactly that. They have variable terms, two different x's, but one on each side of the equal sign. Okay, and if you watch my previous videos, you see that, or you know that I explain this equal sign is it's like a roadblock. It's like a barrier between that breaks up the two sides. But this equal sign barrier gets us in the way of being able to combine any terms. So what we have to do is start to use our inverse operations here. Okay, because again, I can't combine anything across the two sides. And I can't, what kids often try to do too is combine, like, okay, 4x minus 8, that gives me negative 4x. That's a common mistake kids make. And you can't do that. Why? Because these are not like terms. These are not two terms that we can add or subtract because this has an x and this one does not. So can't combine them. So what are our options? Well, again, I said our goal here is to get it to a place where we can recognize what to do, right? Hopefully with two-step equations, you see the pattern where you add or subtract something and then you divide at the end and you get your answer. Okay, let's get it down to a place where it looks like that. We can use inverse operations still here, okay? If I wanted to cancel out this 2x, how could I do that? Okay, well, think about it. Well, a lot of kids would think, okay, divide by 2 or divide 2x from both sides. But this 2x is just a single term, like another one, okay? Just like how 2 minus 2 equals 0, 2x minus 2x is also going to equal 0 or 0x. And that makes this cancel, okay? So if I have positive 2x's and I subtract 2x's from that, I have no x's left, 0. So that cancels, okay? And that's key because once I do that, I get rid of one of my x terms. So I think that should be a good step one for you. Every time you do these is cancel out one of your variable terms, okay? Oftentimes, I'll explain this more, but I like to cancel the one on the right side. I'll explain that in a little bit. But if I minus 2x from here, what's our golden rule of algebra say? Well, it says, okay, I have to do that same thing on this left side to keep it in balance, right? If I only subtract 2x from here and not from here, it's then out of balance. It's no longer an equation that's equal to each other on both sides. So I have to do the same thing. And I'm going to minus the 2x from this term. I'm not going to do it from this one. Why? Well, if I'm taking 2x away from this side, I can't take away 8 minus 2x. I can't take 2x away from this because that's not that type of term. I only need to subtract it from the type of term that it's the same as, right? And this is a 4x, a variable term with an x, and this is a 2x. So I do that. What am I left with? Look what happens here. This is cool. 4x. So if I have 4x's, I take away 2x's, I have 2x's, just like a subtraction problem. It's just with an x on the end. So 4x minus 2x gives me 2x. And then whatever did not get affected by the problem, you just bring it down the exact same that it was. Okay, so minus 8 equals positive 10. And I don't need to write that plus because when I write 10, that implies that it is positive. And now look at this. 2x minus 8 equals 10. Now this is where, this would be like the two-step equations that we did before that hopefully you recognize. And that's awesome because, again, math is all about getting it to a place where you're comfortable, okay? Getting it to a place where you know exactly what to do, okay? And hopefully with this one, you know exactly what to do, okay? But again, it just took that extra first step to do that, okay? I'll walk through a little bit more, but hopefully you see what I mean by that. And again, our goal is to get this x by itself. And now I went from having two numbers with x's to just one. So now I can pinpoint, okay, this is the x I want to get by itself. So these are the numbers I have to cancel to get that by itself. So I think, okay, minus 8. That doesn't have an x, so I can cancel that right now. Minus 8, how do I cancel that? With a plus 8. Plus 8, and I do it to both sides because that's the rule, right? So I cancel it. What didn't change comes down, so I get 2x equals 10 plus 8 is 18. So now it says 2x equals 18, and again, there's a multiplication here that it's not showing. So you think 2 times x equals 18. I cancel out this multiplication with division, right? That'll get this x by itself like I want it to be, and then I divide this side by 2 as well. So I get 18 divided by 2 is 9. X equals 9. Okay, now again, pause the video if you want. Practice these problems yourself, and I'll go through them here in 3, 2, 1. Okay, here we go. So going through these problems, again, there's variables on both sides. Okay, so it's really key, especially with longer problems. First thing you should do, locate where your equal sign is, draw that barrier line right down the middle, okay? Sometimes it's not right down the middle, though. Sometimes there's like 10 terms on the right or on the left, and then like one term on the right. It doesn't matter. That equal sign is where you draw that, okay? Because that splits up your two sides, okay? So here we go. So again, what my goal is, what I want to happen is, I want to get it down to where there's just a single x term left. Because then it's easier to cancel out, you know what numbers to cancel then, right? And that's so often the problem with these is kids don't know where to start, okay? So I'm telling you, here's your starting place. Cancel out one of your variable terms, okay? And I keep saying one of your variable terms, but and so often too, I find that kids need the consistency. They just say, okay, tell me exactly what term to cancel out. Okay, some teachers try to say, okay, try to avoid the negative, and that can be helpful. But I think it's helpful to know, okay, here's the term you start with, cancel that one. Okay, with problems like this, there's going to be an x on one side and x on the other side. I'm saying cancel the one on the right side first. Whatever number has an x with it on the right, you cancel that one. Okay, that gives you the structure you need to get going right away. So cancel the x term on the right. So this is negative 10x, and I'm going to add 10x to cancel that, right? Just like over here, 2x minus 2x was 0x, it canceled. Negative 10x plus 10x cancels as well. That'd be 0x, cancels, okay? And so I do that. Again, I have to do that to both sides, and I only add the 10x over here to the term that has an x with it. And so that's going to be this one, plus 10x. Now this is weird. How do I combine these? Negative x plus 10x? How many x's is this? Well, again, it doesn't show it, but the default coefficient, or the default number out in front here, is 1. And it's not going to write that often, but negative 1x is what this is saying. So really the math I'm doing is negative 1 plus 10. And negative 1 plus 10 is positive 9. But again, it has an x, so they're x terms. So it'd be negative 1x plus 10 x's gives you a total of 9 x's, positive 9. Okay? So then again, what didn't change comes down, and negative 7 plus 9x equals 22. And notice, anytime it's a positive, it is helpful to write the plus there, unless sometimes like like in this one, I didn't bring down the 10 because it was the only term over here. So sometimes you don't need to, but that denotes that it's a positive 9x, especially when it's not first in order. You should include a plus to tell you that it's positive and not negative, okay? So now, why did I say to cancel this one on the right first? Again, it's all about that structure. It's all about getting you comfortable, helping you, giving you the structure you need to know where to start the problem. So often that's the hardest part of it. And what this does, when you cancel out the variable term on the right side, what that does is it brings you down to this place. It'll leave you a variable term on the left and then two other numbers, right? But that's what you're used to seeing. That's what's normal, is seeing the variable on the left and just a single number on the right, okay? You could, like here, you could have added 1x to both sides and done that and gone from there. But again, so often it's the consistency. And so I think for most kids, canceling the one on the right will help you to make the least amount of mistakes. I'm going to leave the x term alone right now. I'm going to cancel out the other one. So this -7, I'm going to plus 7 to both sides. And I get 9x equals 22 plus 7 is 29. Okay. And so I get 9x equals 29. And so my last step here is going to be cancel out this multiplication here with division. So divide both sides by 9. And so x is going to equal 29 divided by 9, which unfortunately is a decimal. Okay. I believe it would be like 3.3 something. Okay. Let me grab my phone real quick and check that. I realize I can't check it because my phone is filming. So check on the computer. Okay, here we go. Got it up here. Let's make it full screen. Not full screen, but almost. 29 divided by 9 is 3.22222. So I was wrong by a little bit. 3.2 repeating. There we go. We fixed it. Okay, so that is the answer to that one. Oftentimes you'll end up with a whole number answer, but there are times where you get a decimal. Don't just assume that if you get a decimal answer that it's wrong. It just means like check your work pretty thoroughly. Make sure you got all your steps right. Sometimes you make mistakes, like I did with the 3.3. But anyway, last one here. Last one. -4 times the group 3x minus 4 equals -8x minus 24. Okay, so you see my step 1 is already drawn, my borderline there. Great, so hopefully you remember to do that, okay? But now, this -4, okay, times this group, that looks like something that I can distribute, right? I'm going to distribute because it's a single term times a group. So distributing means multiplying this outside number times each term that is inside the group. So when I do that, I get -4 times 3x, -4 times 3x. Again, I'm just going to multiply the outside, the whole numbers here. -4 times 3 is -12, but it has an x with it, right? So it's going to be -12x. And then the second one, -4 times, you think of this as -4. So -4 times -4, -4 times -4, positive 16. So that's what I get when I multiply these. And then this didn't change. Nothing needs to be distributed here. But we get 8x minus 24 on the right side. Didn't change. Okay, now, again, here's your step. Cancel out your variable term on the right side. Okay, do that. So this is -8x. I'm going to cancel a negative with a plus 8x. Okay, that will cancel. And I do the same thing over here. I only add it to the term that also has an x. So that's going to be plus 8x here. What am I left with? I'm left with -12 plus 8 gives me a -4x plus 16 equals, and this is so easy to miss. So many kids will just write 24 here. This is minus 24. This has negative. So don't forget that. This is going to be a -24. Okay, don't forget the negative. Really easy to do that. So now what's next? Okay, 4x, -4x plus 16 equals -24. Again, now it's great. I have this single x, and I'm just going to cancel these other ones out. So minus 16 from both sides. So I get, on the right here, I get -24 minus 16 more takes me all the way down to -40. Okay, and so this on the left, it's -4x. That didn't change. So -4x equals -40. Okay, last step. Again, this is connected to the x by multiplication. So I don't add it to both sides. I'm going to divide it from both sides to cancel out the multiplication. So I divide both sides by -4. Okay, and so -40 divided by -4 gives me a positive 10. X is positive 10. Okay. Now there's a few other equations of variables on both sides. I'm probably going to put another one up, another video up, but hopefully that was helpful as a brief explanation to you about solving variables on both sides equations.